was it? It was like no music in, or for no music in math, exclamation point. Because he thought it was funny that they flagged me because I use Google in my classroom. What was it? It was like, woo, okay. All right, so here we are. We are solving using substitution. I'm assuming you guys remember that substitution means isolate a variable and plug it into the other equation. If you didn't know that, you might want to give yourself some steps. Isolate a variable, plug in to other equation. But before we can isolate a variable here, it would probably be helpful to eliminate all those fractions. And we know how to do that. How could we eliminate all of these fractions in one simple step? What can I multiply both sides of the equation by? 15, the least common multiple, right? Between 3 and 5. So if I distribute a 15 to this side and a 15 to that side, that's legal, because as long as you multiply one side of the equation by a number and the other, then it's balanced. I distribute this in. 3 goes into 5 times, so I have 5 times x, plus 5 goes into 15 3 times, so I have 3 times 2y, equals 4 times 15, which is 60. I'm going to go ahead and change that. 3 times 2y, I'm going to call that a 6y. Now, looking at the other equation, x plus y equals 11, you can choose which variable to isolate. In my opinion, the second equation is easiest. You can choose x or y. Let's just stay on the same page. What do you guys want to get by itself? X, okay, so we'll have x is equal to 11 minus y. Then, now that I've isolated the variable, I'm going to plug it in for x of the other equation. So I do that, and I have 5 times quantity 11 minus y plus 6y is equal to 60. Do make sure whatever you plug in, you do it in parentheses so you don't miss the requirement of the distributor property. So I have 55 minus 5y plus 6y equals 60. Combine like terms, and that's 55 plus y equals 60. Subtract 55, and I get y is equal to 5. Now you guys probably remember, but what do we do after we have one variable? Plug it back in. So I plug it in for y of the other equation, and I have x is equal to 11 minus 5. So x is equal to 6. Now, rather than writing it x equals y equals, I will always ask you to write it as an ordered pair. So xy would be written as 6, 5. And the reason I ask you to write it as an ordered pair is because this doesn't only mean one point algebraically, like with just algebra, this also has some meaning graphically. So let's go ahead and consider, what does this solution mean on a graph? On a graph, we would solve for y. So I would go ahead and take this equation, solve it for y. I'm going to graph both of those equations, and then I'm looking for a specific value. So if I solve this for y, I have 6y is equal to negative 5x plus 60. Divide everything by 6. And I have y is equal to negative 5 over 6x plus 10. And then if I take this equation also, solve for y, I'll get y is equal to negative x plus 11. I know I didn't give you an xy coordinate plane. I probably should have, but we could go ahead and just kind of sketch this. That's a linear equation, so we can use slope-intercept form. What would be the y-intercept of the first equation? 10. What's the slope? Good, negative 5 over 6. So I would graph that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I would go down 5, 1, 2, 3, 4, 5, right 6. And this is just a sketch. If I had an XY coordinate plane, it would be a little easier to be accurate. but we just really want to know what we're looking for since we've already solved this. If I plot the next equation, I have a y-intercept of what? Positive 11, good. And what's the slope? -1. So I have a y-intercept of 11, and I would go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. I should keep going down and right until I hit the point 6, 5. And in fact, I know this is a sketch, but essentially this is going to look like this. What we have to remember is, what does this solution mean on a graph? What is it? The coordinate where the two lines do what? Exactly right. So it's the point where the lines intersect. If I asked you what's the solution to one line, you would say every single coordinate on that line. But now when I ask you what's the solution to two lines, you're looking for the coordinate that both lines share. You're looking for the point that would make both equations true. So you could check this graphically. Do they cross at this point? Or algebraically, to check, you would plug the point into both equations and make sure that the equations are equal on both sides for both. So to check, you'd plug in the point to both equations. To make sure it's true. Make sure both are true. Now, sometimes I have students just plug it into one and they're surprised they get the answer wrong. That's because if you truly have a solution, it has to work for both. And they made a mistake somewhere in their work, and that's why it got wrong. Okay, that was a lot of review in one question. Any questions on that? Wilbur.
Will you ever have like parallel lines, meaning that there's no
Oh, Wilbur, you read my mind. That's coming, but not till the second page. Okay. So yes, is it possible we could have parallel lines and then no solution? Definitely possible. All right, let's move on to method 2, elimination. What I'd like you to do is, we want to get rid of all these fractions to make our work easier. So turn to your partner, the person with the most pets. So you're gonna have to ask your partner, how many pets do they have? You share what you would do to get rid of all these fractions. Evan, how many pets do you have?
I have 2 dogs.
You have 2 dogs, you win. I just have 1 dog. So Evan, how would we get rid of these fractions? What would we do with the first one?
You'd multiply it all by 10.
Awesome. So let's go ahead and do that. We would get 2 times x plus 6 plus 2y minus x equals 10. You guys, after you know what to do to eliminate the fractions, go ahead and line up the x's and line up the y's as you would in the process of elimination. Okay, so Evan, we'll distribute this. We got 2x plus 12 plus 2y minus x equals 10. 2x plus negative x is x, plus 2y equals, if I subtract 12 to line up the constants, I will get negative 2. And then for the other equation, Evan, what would we multiply this equation by?
Can we do 20?
Nice. So then we'll get 5 times quantity x plus 2 plus 4 times quantity 3y plus 2 equals negative 60. That gives us 5x plus 10 plus 12y plus 8 equals negative 60. All right, guys, I had you just share with your partner what you would multiply by to get rid of the fractions. But now what I'm doing is I'm getting the x's and the y's together and the constants on the other side. So I distributed the 5, I distributed the 4. 10 plus 8 is 18. So I'm going to subtract 18. I'm not sure where you guys are in your work. but I have 5x plus 12y is equal to negative 78. Did you guys get these two equations? Okay, now in the process of elimination, we want to line them up. So I'm going to bring this one right down here. X plus 2y equals negative 2. It's okay. And let's see what you guys remember. In eliminating, you want to get a variable, and it's what we call additive inverse below, basically meaning a variable and its opposite. So when they add up to 0. So which variable do you guys want to choose to eliminate, the x's or the y's? The y's? Okay. Then what would we multiply the bottom equation by? 6 or negative 6? Negative 6 would be easier just so that we could add those together. So if I multiply that in, I will have negative 6x minus 12y equals, do be careful to distribute all the way through. What's negative 6 times negative 2? 12, good. And then just because it's not lined up very nice, I'm going to go ahead and reline it up. 5x plus 12y equals negative 78. And then we add straight down. In some countries, I think this is called the addition method because they add straight down. Negative 6x plus 5x equals negative x. 12 plus negative 78 is equal to negative 66. Divide by negative 1, and I get x is equal to 66. If you did not know the process of elimination, make sure you know that, or write in your steps, line up your variables, and then add straight down. Okay, now what do we do to find y? Plug it in. Now you can plug it into any equation, but you do want to be careful in case you made an algebra error, then you're going to continually make algebra errors when you plug it in. I like to plug it back into the original equation, but it really doesn't matter where you go as long as you didn't make errors. How can we check to see if we make errors? Plug x and y into both equations and make sure that they both come out true. So let's see, Wade, where do you want to plug x into? We can. You want to do the original? The top one? Okay, so then I would have plug that into for x, and I would have 66 plus 6 divided by 5 plus 2y minus 66 divided by 10 equals 1. 66 plus 6 is 72. 72 fifths. Oh, no me gusta. I'm going to get rid of all these fractions. So if I got rid of all those fractions, what would I multiply that by? 10. Makes it easier for me. I have 2 times 66 plus 6 plus 2y minus 66 equals 10. 66 plus 6 is 72. 72 times 2 is 144. 144 plus negative 66. That's a tough one. What is that? 178? No, I mean 78?
Yeah.
Is it 78?
Yeah.
Thank you. 78 plus 2y equals 10. Subtract 78, and I get 2y equals negative 68. Divide by 2, and I get y is equal to negative 34. But again, I want to write that as a point. So as a point xy, I would have 66, negative 34. This might be a really good one to just check, make sure, hey, does it make both equations true? Logan.
So I plugged in like one of my last equations and it still works, so that'd be fine.
That's fine. You just really, you want to make sure, Logan, that if you plug it into one of the ones that you've manipulated, you check. Because in case you manipulated that equation wrong, you're going to get the wrong solution. So, but you would still get the wrong solution even for the original. So you just want to make sure that you really check that. All right. Any other questions on that? Okay, so after we reviewed substitution, graphing, elimination, you can choose any of those methods to solve based off of the problem given to you. But understanding all three methods is important because sometimes one of the methods is easier depending on what situation you have. So let's go ahead and move to the other side. So now solve the following, choose any method that you want, but then make sure to isolate y in the equation and sketch the graph using your calculators. Make some conclusions based on your results. So this first equation, my preference would be elimination since x's and y's are already lined up. So if I was to eliminate x, what would I multiply both equations by? 2, good. So then I would have 6x minus 4y equals 8. Add straight down. Those cancel, adding to 0. Those cancel, adding to 0. And I get 0 equals 15. That doesn't make any sense, right? It probably means no solution, but let's make some conclusions after graphing. So if I graph this, so I'm going to take this equation and I'm going to graph it. So which variable do I need to solve for? Good, solve for y. And that gives me negative 2y equals negative 3x plus 4. Divide both sides by negative 2. And I would get y is equal to 3/2 x minus 2. And then let's do the same thing to the other equation. So solve for y. We have 4y is equal to 6x plus 7. Divide both sides by 4. And I get y is equal to 3/2 x plus 7/4. How do you know they're parallel, Michelle? They have the exact same slope. And we learned back in geometry that if two lines have the same slope, then they are indeed parallel. Same slope, therefore parallel lines that will never touch. So if I'm looking for a point that makes both of these equations true, will there ever be a point?
No.
No. So what does that mean? What should my answer be? No solution. Now here's what I want you guys to see. Whether you're solving this graphically, you'll find lines that don't touch. Algebraically, you will end up with a false statement. If it's false, then you know this situation is occurring. Same slope lines, they're parallel, so they will never touch. I never want you to answer false. You have to answer what's happening here. No solution. There's no place that these two lines touch.
You can just tell from that.
You could tell algebraically here. You don't have to go all the way through graphing, but in case you were graphing, that's what it would look like graphically. Logan.
So do you have to say that they're parallel, or can you just say no solution?
You can just say no solution. But this is us like thinking through why is it no solution, because they're never going to touch. All right, let's do the same thing for the second situation. If you want to eliminate x, what would you multiply the top equation by? -2. So I'm going to distribute that in, and that gives me -4x minus 6y equals -12. I'm going to add that straight down. Any number and its opposite adds up to 0. So I get 0 equals 0. Is that a false statement? Can I just say no solution?
No.
No, that's a true statement. So now I want to think graphically, what does this mean? I'm looking for where do these two lines touch. So let's go ahead and let's graph these. Graph. So I'm going to solve for y. And I have 3y is equal to -2x plus 6. Divide everything by 3. And I get y is equal to -2/3 x plus 2. And if I graph the next line, I get 6y equals -4x plus 12. Divide by 6. And yeah, Michelle told me that it's going to be the same thing, -2/3 x plus 2. Okay, so let's think about this graphically. They're the same line, true. So if I'm graphing that first line at a y-intercept of -2 and a slope at -2/3 down to right 3, every single point on this line, every xy is a solution to that line. It will make, any ordered pair will make this equation true. And if I graph this line, y equals -2/3 x plus 2, every point on that line makes the equation true. There are an infinite number of solutions. This is true, but if I answer just infinite, would this point work, 0, 0? No, so I can't quite say infinite. It is true that they cross at every point, but they only cross at every point on this line. So let's just make a note of that. They intersect, that's a better word. They intersect at every point on this specific line. So how do I answer that as an ordered pair? Daniel?
X -2 x plus 2.
Exactly. So what Daniel's saying is that every x, so sorry, these two questions were to lead us to that, but we already answered this question. If there are an infinite number of solutions to an equation, does that mean any ordered pair you can think of as a solution to the set of equations? The answer is no. You can see that 0, 0 doesn't work. So Daniel, answer the next question for us. So how do we write the solution to an equation with an infinite number of solutions as an ordered pair? Every x works that fits this y. Every single x works that fits this output. What is that output? -2/3 x plus 2. And that's what tells the reader that it's not just infinite. You can't choose every single point on the xy coordinate plane, but you can choose any point that matches that line. So any real number that when you plug it in, you get this y value out, that is truly your answer. Any questions on that? All right, let's try this last one then. This time, solve this one with your partner and the person with the most siblings. You start the question. Tell them what you would do. Evan, how many siblings do you have?
I have no siblings.
You have no siblings?
Nope.
I've got 2. I've got a younger sister and an older brother. So I'll start this one off. I'll use elimination, and I'll multiply the top one by 4 and the bottom one by -3 to eliminate x. So that would give me 12x minus 24y equals 48. And the bottom one, I'd have -12x plus 24y
The top one
equals -48. And then I add straight down, and I get 0 equals 0, which is true. So it's not no solution, but I need to answer it as an ordered pair. So I'm going to have x, comma, how should we figure out our y?
Y equals 1.
Do you just put in like the wait? Do you just put in like the I don't know, wait, what? I'm kind of confused. You
So-
put in wait, sorry, you just continue.
Oh, you could, did you have something?
No, I'm not too sure.
So I need y to like equal something. So to determine what y equals, I just solve, because these are the same equation, I can solve either of them for y.
You're right.
So I'd have negative like 8y equals -4x plus 16. And then divide everything by -8. And I get y is equal to 1/2 x minus 2. So then that's what I can put for the y.
Okay. All right, I think I get it now.
All right, guys, Evan and I solved and we got like 0 equals 0, which we know is true, which we know means infinite solutions. But then the question was, how do we represent this as an ordered pair? Basically, we need an x and we need what y equals. This one was a little tricky. You have to get y by itself so that you can determine what y equals. Now you don't have to say y equals. I was just looking for what is the value of y. You can just say x and then comma, this is how we get y when we plug in any x. Any questions on that? All right, once we have our skills down, we can apply them to different types of maybe real life situations where we can use x and y to represent unknown values. So let's try this with number 1. It says a box of coins has dimes and nickels totaling $4.20. If there are 3 more nickels than dimes, how many of each type of coin is in the box? Okay, first thing to do that's often helpful is define your variables. What are you solving for? So we're looking for dimes and nickels. What do you want to call dimes? D? Now is D like the value of the dimes, or is it the number of the dimes?
Number.
It's hot. Then what'd you say, Johnny?
I said number.
It's the number, because we're looking for how many dimes do we have. We are going to have to use the value in the equation for sure. But when I'm solving for, I'm looking for how many dimes are actually in the box. Okay, let's use n for nickels, and n is the same thing. I'm looking for the number of nickels in the box. Now, looking at the question, I'm going to set up equations based off of what I see. So number 1, it says a box of coins has dimes and nickels totaling $4.20. So now we're not talking about how many dimes and coins specifically. We're looking at the value of the coins equals $4.20. Well, what's the value of a dime? 10 cents. So if I want to determine what are the value of the total dimes that I have, Michelle? 0.1 times, yeah, D. Because the dime value is 10 cents. If I have 10 dimes, I have 10 cents times 10 is $1. And then I'm going to add that to, what's the value of a nickel? 0.0 penny would be 0.01, which should be good. The nickel will do 0.05. So we've got 0.05 times n is equal to $4.20 because that's our value. If there are 3 more nickels than dimes, how many of each type of coin is in the box? So now I'm looking at the quantity. If there are 3 more nickels than dimes, I like to start up with which one's greater. Which one's greater, the amount of nickels or the amount of dimes? The nickels, because there are 3 more nickels than dimes. So the amount of nickels, since it's bigger, is going to equal the amount of dimes plus what? 3. Because there's 3 more nickels than dimes. So I start off with the bigger one and I say, hey, take the smaller one and add to it. Now, which process would you guys want to use to solve this? Substitution or elimination? Substitution, I agree. Why don't you turn with your partner, and this time the person with the least amount of siblings, you tell them what you would do. So Evan, what would you do for substitution?
You'd plug in d plus 3 for n in the first equation.
Awesome. And we do it with parentheses, right?
Yeah.
So we have 0.1d plus 0.05 times quantity d plus 3 equals
Then
420.
Then you distribute the 0.05.
Awesome. 0.05 times 3 is 0.15, right?
Yeah, wait, yeah.
Equals 420. What would we do next?
You combine the 2 d values.
So 0.15d.
Then you'd subtract 0.15 from 420.
Awesome.
4.2.
Good. So we get 4.05. And then what?
Then you just divide by 0.15.
Nice. And then I need to get my calculator up. I don't know that in my head. 27. And then we can plug it in, right?
Yeah.
So the amount of nickels is 30. All right, guys, you should get nickels. The amount of nickels is 30. The amount of dimes is 27. Notice I just circled D equals and N equals. I can do that since I've defined my values over here. But if I didn't have that definition, I would make sure to tell the reader that there's 30 nickels and 27 dimes. Any questions on that? All right, let's try the next one. Ron Howard is 9 years older than actor Tom Cruise. If the sum of their birth years is 3,915, in what year was Tom Cruise born? Okay, let's define our variables. We've got Tom Cruise. Let's use T for Tom and R for Ron Howard. Is T the age of Tom?
Yes.
Is it his age? So I'm looking for like what? Like, I don't know what he is now, like 56? Is that what I'm looking for, his age, or am I looking for something else?
The year he was born.
The year he was born. So T is Tom's birth year. And R is Ron's birth year. Okay, now let's start one sentence at a time. Ron Howard is 9 years older than actor Tom Cruise. I like to start with the bigger number. Think about somebody that you're older than. Think about the year that you were born and the year that they were born. Who has the higher value of the year? The younger one. So I'm going to start with Tom. Tom is the younger one. He's older, so his year value should have more. How much more? Tom is going to equal R plus what?
9.
9. Exactly right. Tom is the younger guy, so his birth year is bigger. Like my sister, she's 9 years younger than me. She was born in 2004. I was born in 1985. My year value, 1985, is lesser than 2004. So I would say like 2004 equals 1985 plus 9. Okay, so T equals R plus 9. And now we know the sum of their birth years is 3915. So I know that T plus R equals 3915. You could use substitution or elimination for this. If you want to use elimination, you'd have to subtract the R. But we can plug R plus 9 in for T if we want to use substitution. And I have 2R equals, let's see, 3915 minus 9 is 3906. Divide by 2, and I find that Ron was born in 1953. How do I figure out Tom's age? Plug it in, add 9 to it, and I find that Tom was born in 1962. So, yeah, he's pretty old.
Pardon the interruption. Seniors, today for advisory, you will be going over to the FAC for a senior class meeting. Mr. Bowling's advisory group will meet with Mr. Ellis's group in room 129. Mr. Dykema's advisory group Mr. Bowling's group will meet in Mr. Ellis's room 129. Mr. Dykema's advisory group will